Good morning, everyone. In this class, we are going to discuss about the important climatological topic regarding our UGC NET exam, that is jet stream. Okay, jet streams. Now, what is jet streams? Jet stream is a geostropic wind in the upper troposphere. Okay, the jet stream is a geostropic wind blowing horizontally through the upper layers of troposphere, generally from west to east. Okay, from west to east. Okay, this is the troposphere, this is the stratosphere, and lying between tropopause in these two layer. In upper troposphere regions, the jet stream is blowing. Okay, location extends from 20° latitude to the poles in both hemispheres, and altitude 20° to 20,000 to 50,000 feet on the Earth's surface. Now, jet streams develop where air masses of different temperature meets. Okay, the greater the temperature difference, the faster the wind velocity inside the jet stream. Okay, warm air in the troposphere, tropics rise. Warm air, first of all, warm air in the tropics rise. Okay, this is the process. Warm air is rising upward. Then it hits the tropopause. Tropopause means approximately 58,000 feet on the Earth's surface. Tropopause and located in the border between troposphere and stratosphere. Then this rising air is then drawn toward the colder air at the poles, creating the stream. Okay, and then rising air is drawn towards the colder air at the poles, creating the stream. Okay, that is jet stream. Okay, there are several distinct jet streams with unique characteristics and climatic influence. We will focus on three key types. Okay, first of all, subtropical jet streams, this one, tropical easterly jet, TEJ, this one, and polar night jet stream, this one. Polar night jet streams. Okay, first of all, subtropical jet stream, a bringer of fair weather. Okay, a bringer of fair weather. Key characteristics of subtropical jet stream: blows between 20° and 35° latitudes in both the hemispheres. Best develop in winter and early spring. Then maximum velocity speeds can reach 300 knots. Associated weather, a subsidence sinking motion accompanies the STJ, that is subtropical jet stream, giving rise to predominantly fair weather. Okay, this is subtropical jet stream prevailing between 20° to 35° north and south latitude and 300 knots speed maximum velocity. Then tropical easterly jet stream, the summer monsoon engine. Key characteristics: occurs nearly the tropopause over Southeast Asia, India and Africa region. India, Southeast Asia and Africa. This is the direction. Seasonality, a summer phenomenon. It is a summer phenomenon, and driven processes are driven by the intense heating of the landmass, Tibetan Plateau, compared to the ocean. And thermal structure implies a deep layer of warm air to its north and colder air to the south over the Indian Ocean. The meandering flow, Rossby waves and seasonalities. The characteristics meandering or wheeling movement of the jet stream is called a Rossby wave. This wave motion creates alternating conditions of cyclonic and anticyclonic activities. This is the ridge, this is a trough of this wave, that is Rossby wave. Winter intensification. During winter, the thermal contrast between pole and equator increases. This intensifies the jet streams, increasing their velocities and causing them to extend further towards the equator. This is summer jet, southward shift. This is winter jet. Okay, summer jet is northern portion and winter jet in southern portion. Okay, there's a case study. Conductor of Indian Monsoon. Jet stream is a conductor of the Indian Monsoon. Central premise: the burst and subsequent withdrawal of the Indian Monsoon are not surface level phenomena alone. They are fundamentally controlled by the upper air circulation, dominated by the seasonal migration of the subtropical jet stream. This is the direction: Tibetan Plateau, Himalayas, Arabian Sea, southwest monsoon, southern monsoon wave. This is southern monsoon, and northeast monsoon. This is the northeast monsoon direction. And Bay of Bengal, tropical easterly jet. During the winter, northeast monsoon. This is the movement, northeast monsoon, governed by the subtropical westerly jet. It is governed by subtropical westerly jet, and summer monsoon, southwest monsoon, that is southwest monsoon, and triggered by the subtropical jets shift and the tropical easterly jet. Okay, this is the one case study on Indian monsoon, impact of jet stream. Okay, winter configuration, a bifurcated jet stream. In winter, the subtropical westerly jet streams flow from west to east across Middle Asia. Flow from west to east, this direction, and across the Middle Asia. Okay, the massive barrier of the Himalayan range and the Tibetan plateau bifurcates it. Okay, it's divided into two directions. Okay, Himalayan and Tibetan plateau divide the direction in two different direction. The two branches, northern branch, this is northern branch, blows parallelly to the plateau to its north, like this, and southern branch dives south of the Himalayas, flowing along approximately 25 degree north latitude. This is the direction. Impact, this southern branch is responsible for bringing western disturbance, which cause winter rain and snowfall in northern India. Then how the winter jet powers northeastern monsoon. Okay, northeastern monsoon, high pressure outflow and moisture rainfall. High pressure, the cold westerly jet stream pushes air downwards. This is the direction, creating a high pressure zone on the surface of our northwestern India, high pressure zone. Then dry cold winds began to blow from this high pressure area towards the lower pressure area over the Bay of Bengal. This is the lower pressure area, Bay of Bengal, and high pressure moves from towards this region towards the this region with low pressure region, low pressure. Moisture and rainfall after reaching the Bay of Bengal. These winds peak up humidity under the influence of Coriolis effect. They curve and stack the coast of Tamil Nadu and causing the northeast winter monsoon rainfall. Okay, due to the rotation and Coriolis poles, they move towards the Tamil Nadu and creates the winter monsoon rainfall in Tamil Nadu coast. Okay, this is the winter jet powers of the northeast monsoon. Then the great seasonal shift unlocking the monsoon, the trigger event. With the beginning of the summer, the subtropical jet stream begins a dramatic northward march. The southern branch weakens. Okay, in the beginning of the summer, subtropical jet stream begins dramatic northward march. Okay, this the movement it's towards the north. The jet streams towards the directs towards the north. Then tipping point, by the end of May, the southern jet stream breaks and is diverted entirely to the north of the Tibetan plateau. The signal, this northward movement of the subtropical jet is the definitive first indication of the onset of the southwest monsoon over India. The burst cannot happen until this upper air circulation was switched to its summer pattern. Okay, this is the winter phenomena. This is summer phenomena, summer scenario of subtropical jet stream. And then summer engine, the Tibetan high and the easterly jet. The Tibetan plateau's role, as the subtropical jet stream shifts north, intense solar radiation hits the vast Tibetan plateau, making it a powerful heat source. Then building the engine, hot air rises violently over the plateau, creating a strong high pressure system in the middle troposphere. Air rising from this Tibetan high separates near the tropopause. Our branch flows south towards the equator, becoming the powerful tropical easterly jet stationed around 15 degree north latitude. This is the Tibetan plateau and an Indian Ocean. Tropical easterly jets coming from this direction, and this is topopause, and it's a violent uplift. Okay, unleashing the the southwest monsoon arrive. The final mechanism, the heating of the subcontinent and new upper air pattern create a very strong low pressure through over northern India. Strong low pressure area in the northern area. This is the portion. Then westerly south subtropical jet stream now north helps to pull up surface air and increasing this low pressure. This one. To feel this intense low pressure zone, moisture laden winds from the high pressure area over the Arabian Sea. From the Arabian Sea, this is the Arabian Sea, begins to blow towards the Indian landmass like this direction. And these winds are the southwest monsoon. These winds are the southern monsoon. This is the southern monsoon, and their sudden and powerful arrival is known as the blast of the monsoon. Okay, this is the blast of the monsoon in Western Ghat. And some portion moving towards the northeast India and here's rainfall in northeast India. Master regulators of global and regional climate. Jet streams are far more than just high altitude winds. They are fundamental drivers of weather systems. Their seasonal migration, like dictated by thermal contrast and topography, can trigger the planet's most dramatic climate events, as seen in the Indian monsoon. They play a significant role in atmospheric transport, moving moisture, forming noctilucent clouds, and substances that can impact the ozone layer. Monsoon triggers staying weather systems, atmospheric transport, Rossby wave dynamics. These are some impact of jet streams and impact and as well as importance of jet streams prevailing on the upper troposphere regions on the earth surface in the atmosphere. Okay, that's all for today. If you have any doubt and queries, just let me know in the comment section. Thanks for watching. Thank you.